Hey there, Mr. Sutton here with the AB Calculus 3-7 Part 2 homework solutions on the chain rule. For this problem, we've got a table of values for f, g, and their derivatives, and we're told that h of x is f of g of x. We want the slope of the graph of h at x equals 2, so basically h prime of 2. To get that, we need to first figure out the derivative of h, so that's going to require the chain rule. That's going to be f prime of g of x times the derivative of the inner function, so times g prime of x. And now plugging 2 into all of that, what do we end up with? Well, let's deal with g of 2 first, and then I'll do the primes later on. So g of 2 is going to be this negative 1 from the table here. So this is really f prime of negative 1 times g prime of 2. F prime of negative 1, we can also find that in the table. That's up here, that's 3. And then g prime of 2, that's going to be down here, that's actually also 2. So 3 times 2 then gives us 6, which is good for answer choice D. For this problem, we've got a differentiable function y equals sine of f of x squared. And we want to know the derivative, dy over dx, when x equals 3. All right, well, let's just go ahead and take the derivative of this thing, and we're going to have to use the chain rule for this. So I've got the derivative of the outer function first here. So that's the derivative of sine of something, which is going to be cosine of something, in this case cosine of f of x squared, times the derivative of the inner function. Well, the next function in is f. So we need the derivative of f, which is f prime. So we've got f prime of x squared, times the derivative of the next inner function, which is x squared. So that the derivative of x squared then is 2x. We'll multiply that and add that to the link here. And at this point, we have to plug in 3. So I'm going to have cosine of f of 3 squared times f prime of 3 squared times 2 times 3. Let's clean things up a little bit. This is really f prime of 9, cosine of f of 9, none of which we can do anything with because we don't know what f actually does. We also have a 6 out in front. So let's see here. This is going to match answer choice D, and that's D for done. For this problem, we have the graph of some function g shown here. F is the function given by g of x. It's kind of interesting, plugging a function into itself. We want the value of f prime of 0. So I basically have to take the derivative of g of x and then plug 0 into it. So the derivative here, we're going to need the chain rule since we have an inner function. We're going to have g prime of g of x. That's the derivative of the outer function. Now we have to multiply by the derivative of the inner function, which just happens to be g prime of x. So now we're doing g prime of g of 0 times g prime of 0. Let's start by taking care of this g of 0 business here, and then I'll worry about the primes. So g of 0, I'm just looking up the y value on the graph at x equals 0. So that's going to be, it looks like 3 here. That's what g of 0 comes out to. So then I really have g prime of 3 times g prime of 0. What's g prime of 3? Well, that's going to be the slope of this graph at x equals 3. So if I look at 3, I'm right here. So I basically need to figure out the slope here. Now, it's a straight line, so we definitely have a constant slope. If I can figure out the slope from this point to this point, I've got all the slopes in between. I am going, let's see here, down. This is starting at 5. We're going down 5 and over 5. Well, that's just a slope of negative 1. So g prime of 3, then, we can read off the graph. That's just negative 1. G prime of 0, that's this other slope on the y-axis. Well, here we're going, let's see, up how much? We're down 1 and we're going up 5, so we're going up 6, and we're going over 3. So that's, let's see, 6 over 3, that's a slope of 2. So negative 1 times 2 just comes out to negative 2, which ends up giving us answer choice A. For this function, to take the derivative of all of this, I'm going to need the chain rule. So let me start by figuring out my outermost function. So the third power is the outer function. I could actually rewrite all of this as sine of x squared, all of it raised to the third. So I have to do derivative of something to the third to start with. And that's going to be 3 times something squared. So in this case, I'm going to have 3 times sine squared of x squared. My next function in is the actual sine function itself. So derivative of sine of something is going to be cosine of something, so cosine of the inner function of x squared here. And then finally, I need the derivative of the innermost function, derivative of x squared. That'll be 2x that I'm multiplying by. And let me just clean this up a little bit so it matches an answer choice. We just have a coefficient of 3, and this 2x can get multiplied by that. So this is going to be 6x times sine squared of x squared cosine of x squared, which fortunately matches answer choice E. To find the derivative of this function, we're going to have to apply the chain rule. So we have the outer function here, which is the second power. This is really all cosine of 3x, all of it raised to the second power. So we have the derivative of something to the second, which is going to be 2 times the something to the first. So 2 times cosine of 3x. That is our derivative of the outer function here. The next function in is the cosine function itself. So derivative of cosine is negative sine. We'll have negative sine of something, negative sine of 3x, times the derivative of 3x, which is going to be 3. Cleaning this up a little bit, we have a 3, a negative, and a 2 out in front, so that's negative 6 out in front. Negative 6 times cosine of 3x sine of 3x. And that is going to match answer choice A. For this problem, I'm trying to find f prime of pi over 6 for tan of 2x. We'll start by finding f prime in general. So we've got the derivative of tan of something. That's going to be secant squared of something, so secant squared of 2x, times the tail, the derivative of 2x, so that's times 2. And now plugging pi over 6 in here, we've got 2 secant squared of 2 times pi over 6, which would be pi over 3. So we have to actually simplify this without a calculator because the answer choices don't have this stuff in it. So pi over 3, let's see here, that's 60 degrees. Secant is really 1 over cosine of that. Cosine of 60 degrees is going to be 1/2. So this is really 2 times 1 over 1/2 squared. And then let's see here, we've got, this is really 2 over 1/4 then. Same change flip, this is 2 times 4, so that ends up coming out to 8. So choice E. For this problem, we're trying to find y prime for this expression. So I'm going to need the product rule on this one. No other way to do it. So I've got u prime v plus uv prime. And now for the box and ribbon, we've got x and square root of 2x plus 5, which I can rewrite as 2x plus 5 to the 1/2, just to make it a little easier to take that derivative. So we've got derivative of x, which is 1. Derivative of this stuff, which is going to be 1/2 times something to the negative 1/2. So that's 1/2 times 2x plus 5 to the negative 1/2 times the derivative of 2x plus 5, which is 2. And we'll clean that up when we put it back in here. So using my ribbon, I've got 1 times 2x plus 5 to the 1/2. So that's, we're going to need to simplify things, so I'm going to immediately turn that into radical 2x plus 5. Going the other way, we've got plus x times this stuff. So the 2 and the 1/2, I'm going to go ahead and cancel those out now. So we've got x times 2x plus 5 to the negative 1/2. I can write that as x over radical 2x plus 5. And now I have to combine these here. To do that, I've got to get a common denominator, which is going to be radical 2x plus 5. So this is going to be then 2x plus 5 over radical 2x plus 5 if I multiply this by radical 2x plus 5 over itself. And now combining the numerators here, because we've got the same denominator, this is going to be 3x plus 5 upstairs. Still have radical 2x plus 5 downstairs. And does this match an answer choice? It does. Answer choice A. On this problem, I've got this graph with the functions f and g represented, and they also drew a couple tangent lines for us. And they're telling us b of x is g of f of x. We want b prime of negative 3. Well, to get b prime, I need to do the chain rule on these functions. So I'm going to have the derivative of the outer function, so g prime of something, so g prime of f of x, times the derivative of the inner function, so times f prime of x. And I'm actually doing g prime of f of negative 3 times f prime of negative 3. Let's deal with this f of negative 3 first, then we'll deal with the primes after that. F of negative 3, if I look at the f function here, at negative 3, the x value negative 3, I have a y value of 1. So this is really g prime of 1 times f prime of negative 3. And now for the primes here, I have to look at the slope on these graphs. So g prime of 1, that's going to be, let's see, down here at x equals 1. So let's see here. It looks like this slope is going, what's the slope here? We're going from like a negative 3/2 down to 3, and it takes us a distance of 3 to do that. So we're going like down 1.5 over 3. So that's like negative 1/2 for the slope, and it looks like about a slope of 1/2 if you just go one square at a time. So we'll call that negative 1/2. Now for f prime of negative 3, that's the slope at negative 3 here. Fortunately, the f graph is the same slope all the way across, so we actually just have to take a look anywhere on here. It looks like we're going up 1 and over 3, so that's a slope of 1/3 no matter where you go. Negative 1/2 times 1/3 is going to be negative 1 over 6. So that's going to be answer choice B. On this problem, I'm trying to find the derivative of all this stuff. So I'm going to need a chain rule for this one. This is going to be the derivative of the outer function, which is squaring. So I'm going to have 2 times cosine of x cubed. The next function in is cosine itself. Derivative of cosine is negative sine, so we'll have negative sine of something of x cubed, times the derivative of the innermost function. Derivative of x cubed is 3x squared. And now we just have to clean this up a little bit to match an answer choice. So I've got a 3x squared, a negative, and a 2. All those things get multiplied together because they're not inside the trig functions. So that's going to be negative 6x squared. And then we still have a cosine of x cubed and a sine of x cubed. And that's going to match answer choice D. On this problem, we have a table with values of f, g, and their derivatives. And now we're just defining an h function. Hey, why not? As f of g of x, and we want h prime of 1. Well, let's find h prime in general, and then we'll figure out how to use this table to find h prime of 1. So h is going to be a composition of functions, which means to take its derivative, we use the chain rule. So in general, we're going to have f prime of g of x times g prime of x. This is literally just the chain rule written out here. So specifically, if we're doing h prime of 1, we've got f prime of g of 1 times g prime of 1. Let's deal with this g of 1 first, and then we'll worry about the primes. G of 1, just looking that up in the table, that's the value of g at x equals 1, and that's negative 1. So this is really f prime of negative 1 out here. Now f prime of negative 1, we can look that up in the table too. It looks like that has a value right here of 5. And then g prime of 1, also in the table, that's going to have a value over here of 2. So 5 times 2 is 10, which gives us choice D. On this problem, we want the value of this really crazy looking function at x equals 0. So there isn't really a short way to do this. We just have to kind of gut it out and use the quotient rule on this. So that would be u prime v minus uv prime over v squared. Let's set up the box and ribbon now. So for my numerator, I've got the cube root of x squared plus 8. And I know I'm going to take the derivative of that using the power rule, so I'll rewrite this as x squared plus 8 quantity to the 1/3 power. In my denominator, I've got the 4th root of 2x plus 1, which I can rewrite as 2x plus 1 raised to the 1/4. Taking my derivatives now, using the power rule, these are both going to be chain rules. So for this first one, I've got the derivative of something to the 1/3. That's going to be 1/3 times the something to the negative 2/3. So 1/3 x squared plus 8 to the negative 2/3 times the derivative of the inside stuff here. Derivative of x squared plus 8 is 2x. And I know I'm going to plug something into this, so let me actually go ahead and simplify this. So I've got, let's see here, x squared plus 8 raised to the 2nd power and cube rooted. That's happening in the denominator. We've got a 3 down there as well, and we've got a 2x in the numerator. So here's what this thing looks like in radical form. All right, let's take the derivative of this next one. So this is going to be 1/4 times something to the negative 3/4. And we're multiplying by the inner derivative, which is 2 in this case. Simplifying this, 2 and the 4 cancel, leaving us with just a 2 downstairs. Also downstairs, we have the 4th root of 2x plus 1 cubed. All right, so now we're going to plug in 0 to all of this craziness, and then after we've done that, we'll put the pieces back together for our quotient rule. So if x equals 0, here's what we have. Up top, we've got the cube root of 0 squared plus 8. So that's just the cube root of 8, which is 2. So that's kind of nice. We also have the 4th root of 2 times 0 plus 1. Well, that's just the 4th root of 1, which is just 1. Also very nice. Here we have 0 getting plugged in the numerator, and that zeroes out the whole numerator. Now the denominator is not going to be 0, so that means this whole fraction conveniently comes out to 0. Over here in the bottom right now, plugging 0 in down here, this is going to be essentially the 4th root of 1 inside. So that's just 1 over 2 for that grand total. Using the ribbon to put it all together, we've got 0 times 1 minus 2 times 1/2 all over v squared, so all over 1 squared. So this is 0 minus 1 all over 1, so just negative 1 when the dust settles, giving us answer choice A.